So today we are looking at solving equations with variables on both sides. So here's a very good problem where I have variables on both sides. I can't have that though. My end goal is to put those two variables together, or however many I have. If I have 3, 4, 5 variables, as long as it's the same variable, I have to condense them all down to one. All right? So if you take a look, I have a negative 2m and a positive 6m. It doesn't matter which one you move to which side, but it's usually helpful to avoid turning your variable negative. So in other words, if I add 2m to this side, I'm going to end up with an 8m, a positive 8m. I like that. Positive 8, that's easy to deal with. If you minus this 6m to this side, you can do that, but now you have to deal with a negative. Now you have negative 8. So if I can keep my variable positive, I try and do that. So no, it doesn't matter if you move the 2m over here or the 6m over here, but just to make your life easier, if you can keep your variable positive in the end, that's what you should do. So that's why I'm going to add 2m to both sides. So that, yeah, and 6m plus 2m is 8m, and my variable's positive, so it makes my life a little bit easier. That's all. If you had moved the 6m to the other side, it would have been fine. You just have to keep track of another negative. And now, guys, once you've done that one step, now it's just like a quiz problem that you could have just done. So what would you do? You should subtract 9 on both sides, and 1 minus 9 gets us negative 8 equals 8m, and then all I have to do is, so my final answer is negative 1. Correct. Now, just a note about checking these. You can still check them. It's still an equation. I keep telling you that any equation, you can check your answer. It's just when you plug it back in, you're going to have to plug in negative 1 in both locations. Because you have two of them, right? You have an m there and you have an m there. So you would have to plug in negative 1 on both. You follow me? Well, I would understand that it would be difficult to follow because there's a lot of side conversation, so it's hard to focus. So if those could stop, that would be great. Okay, so let's plug negative 1 back in, and let's see what happens. What's negative 2 times negative 1? Negative 2 times negative 1. Positive 2 plus 1. Let's see if that's equal to, what's 6 times negative 1? Negative 6 plus 9. Is that true? Is 2 plus 1 equal to negative 6 plus 9? Yes. You just had to plug in negative 1 in both spots. But I know that I'm right. So you can still check your answer. Okay, let's try one like number 3. So if I look at number 3, I notice that I have r's on both sides. I have a negative 4r and a negative 3r. So if I want my variable to be positive, should I add 4r to both sides or should I add 3r to both sides? What's going to make my variable positive in the end? Yeah, if I add the 4r, add 4r to both of them, because now check this out. I have negative 3r plus 4r. What does that leave me with? Positive 1r.
Or just R.
Mm-hmm. And then I'm almost done. All I have to do is minus the 1, and I'll be done.
No. I got 4 equals R.
Let's jump ahead to one like number
11.
Number 11.
11.
Let's start on 9. Here's an example of a time that I have more than just 2 x's. I have 3 of them. So the first thing that I would recommend you do is simplify each side. Can I do x plus 5x? What does that get me? 6x. And now I can go from there. So now there's only 2. So at least I went from 3 down to 2.
Can you do 6 plus for 3x?
You'd have
Um,
to become negative. So you do minus 3x.
Yeah, I would minus the 3x here. You could minus 6x from both sides, but then you're going to have, on the left-hand side, since you took everything away from it, you would be left with a 0. You're actually making more work for yourself.
No. So now it's like 6x
Oh.
equals negative 12 plus the 3x. Can you do the 6x plus the 3x?
Yeah.
Oh, plus 3x and then minus 12?
You can't just add those together.
It's on the outside again.
No. Yeah, you can't add, because, yeah, they're on the opposite sides of the equal sign. So the only way to get them together is to subtract 3x or to subtract 6x. Yeah. So let's minus 3x. So 6x minus 3x is 3x. Negative 12, and those are gone. So now all I have to do is divide by 3. Now, I do want to show you something. So I ended up with a negative 4. I just want to rewind. Let's go right back to this once we had combined those two. Remember how I keep...
What went wrong? I
Did
forgot
you-
that. I didn't know that. The negative, I didn't see the negative.
Okay. So, I keep telling you that it doesn't matter if you move this number over, the 6x over here or the 3x over here. I prefer to move the 3x over so that it keeps this positive. However, you can move this over here. If I subtract 6x from both sides, you can do this. It's not mathematically wrong, but what's left on your left-hand side? There's a 0 there. 6x minus 6x is a 0. So now on this side, you have, what is 3x minus 6x?
Negative 3x.
Negative 3x. So now you're here. You can still do this. What would you do now? Add the 12. It just makes more work for you. So I would avoid making one side completely equal to 0 if I could help it. You'll see, I mean, I am still going to get the same answer, but it took me a couple more steps to get there.
And then the answer's in reverse.
True, but they're the same, right? Yeah. So you can have it either way. So try not to take everything away from one side if you can avoid it. But yeah, what do you think? Not too bad, huh? So